Hiya there, YouTubers. It's been quite a while since I made my last video, so seeing as I'm getting back into the mode to do some nice summery warm work, the weather's got a bit better, so you're not outside with your hands freezing off. So I'm about to do some welding. I'm currently restoring an old Volkswagen camper van, and as you will be able to see when I move the camera around, there are bits, CB joints, there are mirrors, there's dash, gearbox I've just rebuilt and paid. There's stuff all over the workshop, so don't judge me by my mess. It's not normally like this. However, right, seeing as I'm getting back into doing a bit of work on my own stuff, I haven't used my welder I think now since about September, so what's that, 6-8 months. And I thought I'd do a video to show you the types of things to check for when you're recommissioning your welder, having kind of left it for a while with no use. So first things first, this is my welder. Yeah, I don't know, you might have seen it before. It's in the background. It hasn't got a lead roll, but it's got a supporting roll in my previous video. But in this one it is the main attraction. I'd just like to point out or preface this video by saying that if you're looking for one of these squeaky clean videos with nicely edited and all pop-up messages and stuff, you can move along. Don't know how to do it, don't want to know how to do it, don't want any comments about what a dodgy video, etc, etc. So if you're looking for that, move along. Right, anyway, down to business. Some of the things I'm going to show you seem like common sense. In fact, to be fair, they are. But, you know, like with all common sense things, when you're in a rush, you tend to overlook them. And I seem to always be in a rush. I scrape a couple of hours here and there to do a bit of work on my own stuff. So I would be probably my own worst enemy when it comes to that. So I'm going to cover some fairly basic stuff and then a little bit of nitty gritty to help you get the best out of your machine straight from a bit of a retirement, basically. So first things first, like with anything you're going to plug in, the first thing you gotta check if you haven't used it for a while and it's been shifted around your workshop is the power cord. Now, my welder is a 220 volt, so that's the standard current for most of us here in Europe, but that would be kind of two-phase for you guys in the States. But it is a 32 amp draw, so it's got quite a hefty plug on the end of it. Now basically all I do is, don't bother opening this really. You can open it and check the connections, but it's unlikely anything's gone wrong inside in this guy. So I just run my hand over the cord, looking for any nicks, scratches, cuts. In fact, a mouse could have got in here and decided he might want a little bit of a chew. So just make sure that that's all okay and that it's firmly attached to your machine. And what I like to do with all my rubber cords and flexes is once a year use something like this. I get this from we have this kind of discount store here. I suppose it's the European version of Walmart. It's called Lidl or Aldi. There's two different ones. So they're the Walmart and Costco's of Europe. And we get this kind of own branded stuff. It's a silicone spray. And I like to use it on window rubbers, power cords and stuff like that. I find I guess it's kind of like a moisturizer maybe, but it seems to keep them nice and supple. So I'll give a spray on, or in fact just spray it on a clean piece of cloth and just give it a rub down the length. It helps clean it, helps stop it cracking. I just think it makes it kind of look newer too. So that's step one. Check the power cord. Plug that in, and there's a nick, scratch, cut in it. You could have a bare wire, and well, suffice to say, you wouldn't be worrying too long about whether your welder's going to work well. I think you'd have other things to worry about. Step two, The second thing I check before I even turn on my welder is the gas. Now, as this is a MIG welder, I'm sure most of you will know, it uses an inert gas to shield the arc when you're welding, so you don't get impurities or oxidation of the weld when you're actually on arc. So basically, that's held in this big container here. I believe this one is current. It's about, I think when you get them, they're about 220 bar, or yeah, about 3000 psi. So while it's not going to burst into flames anytime soon, it is still a pressurized vessel, and I have actually witnessed one of these being dropped and the valve snapped off here. You see it here? The valve, it basically broke right here at the neck, and this yoke, this cylinder took off like a rocket. Literally flew through a solid concrete wall of a workshop. So while it won't explode on you, it's certainly not to be messed with. So what I like to do when I'm just turning it on again for the first time for a while, you know, it's been shifted around the workshop here over the winter. It might have had something dropped on it, you know. I'm not the only person that uses this space, and I certainly have some brothers who might not be as careful, let's say, but certainly not intentional. But you know, something could fall on it. It could crack one of the dials. You might not notice it. It might not even be that bad to hear the gas coming out, but it's a good idea to check anyway, because you know, at worst, you're just not losing gas. All of these things cost money. Everything, all the bits and pieces I'm going to talk about, all cost money, and all together cost a lot. So, first thing I'd like to do with this is, before I even crack the cylinder with the valve wrench here, I'll just get one of these bottles. This is it's a branded one, but it's not. I just put some liquid washing detergent, or dishwashing detergent in there to get a good, get lots of suds, lots of bubbles. And I just give it a spray all around where the gauges are and where all the joints are, and then I turn on my gas. And what you'll see is, if you've got a leak here or something's come loose, you'll get little bubbles. This is an old, I'm not inventing this, this is an old trick. So there you go, gauges up, gas on, no obvious signs of bubbles, so that's good to go. So while it's all wet and got a bit of detergent on it, why not seize the opportunity just to give it a bit of a dust off. My grandfather always used to tell me, you know, you buy good things, you buy them once, you look after them, you maintain them, you service them, and you keep them basically, hopefully forever. I believe that with tools, and certainly believe it with cars. My current motor is nearly a 20-year-old now, it's a 1998 BMW, which never lets me down, but it's paid. Anyway, that's another story. So, gas, regulators, bottle, the joins at the pipes, which are, you know, the feed pipe goes on here, and this screws down into the regulator valve here. They're all checked, no leaks. Also, what I'll just run my hand down along the feed pipe just to make sure again there are no obvious signs of potential leaks from there. So, okay, so we're on to number 3. So we've got power cord, we've looked at the gas. Third thing is, I always make sure that I check the ground wire. Now, this is often the poor stepchild of the welding cables. You know, this is the one that gets thrown on the ground. It kind of ends up in puddles. It might get driven over the odd time. You know, it's not really as looked after as the main MIG torch, and as such gets covered in crud. So in here, I'm sure you guys are well aware, there's normally copper plates, copper contact surface area, and you know that can get dirty, and it can certainly get corroded if you've got a bit of a damp or a damp garage, get corroded during the winter. So just take a bit of sandpaper. This is some kind of heavy duty, it's a 40 grit, it doesn't have to be that, it can be anything really, and just give it a bit of a sand off. Now, you're not looking for, you know, a jewellery style polish finish here. Just get the dirt off it, you know, make it kind of clean enough so that you can see there's a little bit of a shine to it. So when it clamps on the metal, you get a good contact. Okay, so that's the third thing. Earth clamp, ground clamp, make sure the contacts. And while you're here, just make sure that this, you know, this again, because it gets a bit of a rough treatment, you know, just check your contacts, make sure the little copper wires, copper strands here and the wires haven't frayed too much. You know, you want that to be as robust as possible so you get a good contact, otherwise you're going to get some dodgy welds. Okay, next thing is to check the actual torch itself. This is a fairly kind of heavy duty torch. Some of the ones on the cheaper machines will be just, actually sometimes they're easier to use, to be honest. This one is pretty heavy duty. It's got a good size cable on it, but hey, had the money at the time, bought the strongest one I could get. Figured it'd last me as long as possible. And one of the benefits are with a slightly more robust and more industrial type of torch is that you can buy all the pieces separately. So rather than, say, the trigger mechanism goes on a cheaper torch, you go into the shop, you either have to buy the whole trigger mechanism, the whole feed or trigger mechanism. On this one you can buy the trigger separately, the swan neck separately, and all the bits come apart, so you can replace individual components a bit easier. So hopefully saves you a bit of money in the long term. Now, what are we looking for on this? You can kind of see I clearly wasn't a very good boy when I put this away when I was finished doing the last bit of welding. Normally I'd clean this up and give it a sand off and everything, but hey, you don't know, sometimes you're tired and you get a bit lazy. What you're looking for in here is, just as you would do under normal operation, any signs of spatter. See, like that lump of stuff stuck in there. That's not great. You want to get rid of all of that, clean that out. You could do it with a file, screwdriver, anything that goes in there really, and give that a scrape. That's the gas shroud. This is part of the gas shroud assembly. This is a heavy duty gas shroud. Some of the other ones just kind of slide on and you can pull them off. They're on a kind of a springed retaining kind of thing that's on, just screws on here. Black thing with circular steel rings on it, and they just pull on and push off. This one has a threaded insert that threads onto the end of this swan neck, as you can see here. And again, little cruddy in there. Not fantastic, man. You want to get that cleaned up. So I'll give that a bit of a clean out later on. Also, you want to make sure that all of these holes, if you do have this kind of torch, but even if you don't have this type of torch, you will have this kind of, this is a gas feed nozzle. So the gas comes out here, flows in and around this and this, right? And makes a shielding gas area around the actual tip here where your wire protrudes, and helps the weld not oxidize. Now, I was doing this earlier on, I clearly pulled the wire through. The wire basically pokes out the end of this, comes out this little tiny hole here. So again, I'd give that a bit of a rub, bit of sandpaper. The cleaner the better, man. Every little bit of dirt slows down the wire ever so slightly, causes potentially some shorts within the actual nozzle. So you just want to keep it as clean as possible. I mean, you don't have to be obsessive about it, but you know, the cleaner the better, like everything. You know, it's all a combination. Every small little bit all adds up to become a big enough problem to cause you an issue with your weld. So I would clean all that up. Now, if you don't want to take this apart, sometimes you can use one of these babies. This is a MIG pliers. It's actually made for using with MIG welders. And you can see that different to a lot of other pliers. So see, looking around for one. Ah yeah, here's a little tiddler here. You can see how I don't know what you call them, the tines there in the front of it are kind of rounded. This one has very squared edges. And the idea that is you can kind of fit it in the nozzle around the actual wire feed tip, which you can see just right in the center here, and you can give it a bit of a twist and it'll knock off whatever's inside the nozzle, because as I say, anything building up in there can create wire feed issues or in fact a short, and will cause you no end of problems. Again, as this is a rubberized flex and hose, and you've got the wire going through it, you've got the positive going through it, the positive electrode feed, and you've got the gas. So you want to make sure that, you know, no one stood on this, it's not out of shape, it hasn't been cut. You want to do the same thing as I did with all the other leads and flexes. Make sure that that's well intact, okay? Right, in addition to that, you want to make sure down here everything's still attached. You know, you haven't had a strain on the cable too much. This is all still connected in properly to the machine, and that your earth cable is pretty clean, no corrosion on that. Get that back in the machine there. Okay, now one of the most important things to check on a machine when you're kind of recommissioning it after a bit of a time off is your wire and your wire feed. Now, as you know, with MIG, the wire carries the current, but it also melts to create the weld pool and, you know, actually make your nice weld bead. So what you want to make sure is, if I open up the thing here, I'll show you. You can see that my welder, this is a pretty, well, this is about 10, yeah, well, I've had about 10 years. It was a Murex, one of the last ones to be made in the UK. Now they're made in China, they're nearly there but not quite. So you'll all recognise wire spool, feed wire, and this unit down here is actually the wire feed unit. And this is, apart from the power going through your unit, and you know, you turn up and down the power depending on the thickness of the material of what you're welding, how deep the penetration you want in the weld and all of that. This is undoubtedly the most important part of the machine. This is the wire feed motor and mechanism. This keeps the wire feeding steadily through the machine, so you get an even, very even weld. You haven't got, you know, it's not gripping the wire, it's moving slightly faster 1 minute, slightly slower the next. You have a nice bead, then you got spattering. It can be really drive you mad when you're trying to weld. So making sure that this unit is clean, well adjusted and running properly is really, really, really important. And you do that by, this is the clamp which basically squeezes the two rollers together, which pinch the wire, right, and kind of drive it all the way down the cable right down to the torch, okay, and it sticks out the front. So if these rollers aren't either tensioned properly, they're going to slip, they're not going to grip the wire and push it on. But if they're dirty, the same thing happens. Even though you might have the tension set right and it might be gripping, if the rollers are dirty, the dirt or the dust or grease or whatever stuff from your hands acts like a lubricant and it won't push that wire through. And I'll show you now what I mean. So if I undo the tensioner, you see the little, this is an idler roller, this is the drive roller here, which is attached to the motor. It's a metal, heavy metal jobby. This is just a stainless idler roller, kind of like a bearing. And you can see quite clearly there's a lot of kind of brown crud in there, eh? And what this is from is the wire. This wire I bought again from a discount store, from the kind of the European version of Walmart. It was pretty cheap. It was about, I think it was 12 euros. So what's that, about 15 bucks, $15. Does the trick, absolutely fine, but obviously they're saving money somewhere, and where they save money is on the most expensive part, which is actually the copper coating of the steel wire. Now the purpose of the copper coating is to stop the wire rusting. It also aids with conductivity, but mainly it's there to stop the wire rusting. And we can see on this one, I own this spool is only in here since last summer. The last spool I had was a big 25 kilo jobby. It lasted me about 2.5 years, I think. It ran out, and I just ran into the local town and got this one. They happened to have these on sale and stuck it in there. But now that I'm starting to use the machine, I noticed that it's, you know, it's kind of hard on the machine because it rusts really easy. The copper coating is very thin, so any kind of dampness or moisture that builds up in the garage here is getting through the copper coating, and you can see it actually building up here on my roller. See the brown stuff? That's the rust getting worn off the wire as it feeds through. So what I would do is, mine actually comes apart. Some do, some don't. Most you can take the drive wheel out because you can swap it around for different sizes to drive different sizes of wire. I would just take this out, give it a good wipe off with a dry cloth. You can use maybe your airline, or potentially sometimes what's good to use on these is brake cleaner. You know, a kind of a solvent based cleaner that dries really fast. Don't be tempted to use WD-40 or anything like that to clean it off. That'll just cause you more problems because, you know, essentially it is a lubricant in itself. So clean it all up. I'll blow that out later on with my air hose, make it nice and clean, and reassemble. Obviously don't lose any of these parts because they can be quite expensive. Just while I'm here, I point out that one of the benefits of a more expensive machine is the size and robustness of this whole unit. See the big motor? Some of the cheaper little jobbies, yeah, they're fine. Little Home Depot jobbies, yeah, they'll weld a little bit of 2 plate for you, 2mm plate, do a little car body stuff. They're kind of okay. But when it comes to doing any kind of long work, you know, you're welding for a few hours in the trot, you can forget it. They're not going to do the trick for you. You need something with a big drive motor like this. And the benefit is you get an even speed, you get an even wire feed. It lets you at least know that when you set your parameters, that's what they're going to stay like, right? Now, just to illustrate on here, if I get this piece of cloth, it's reasonably clean, cleanish white cloth. Sorry, went off a bit there in the camera. A little bit of cleanish white cloth. If I give this a bit of a rub, a bit hard to do one-handed, you'll be able to see all the rust. See the rust coming off that? Catch it right with the angle. All that brown stuff is the rust coming from the wire, which not only makes it more difficult for the rollers. See all the brown stuff there? It makes it more difficult for the rollers to catch it and to drive it properly. But also, what it does is it's almost like it's like an additional abrasive when the wire passes through your within the hose. There's actually, on my one, it's metal. It's like a big long metal spring. It's called the wire liner, and that's what guides the wire from the motor roller mechanism right down to the end. Some of these things are plastic, and literally you can melt, or not melt, but you can wear a hole in your wire feed liner, torch liner, within about 5 to 10 minutes because of that rust. And I know on this machine that liner is about $80. So you notice your wire sticking, you go buy one, you replace it, you run the same wire through it, not realizing that it's corroded. 20 minutes later you're back to square one. You're gonna check your wire, make sure it's not corroded, make sure it's not rusty, otherwise you will go insane. Because all your settings you'll have thought, okay, you'll have calculated them out, you'll have used the diagram on your machine, or you're just using your favorite setting that you know always lays a good bead, and it's still not working. And 9 times out of 10, if it's not that the metal's dirty, you've got a bad ground, you haven't got clean tip, or your gas is a bit funny, you got to check the wire, man, because your wire could be covered in very, very thin layer of rust and can be causing all those problems for you. So, hope that saved you a bit of time. Get welding, have some fun, and hopefully your projects all come along well during the summer months. Take care.